start walking? Tomorrow. And I believe this is the easiest of the 3 lessons we're doing. My opinion. Has anybody ever heard of Pascal's triangle?
Yes.
Oh, yeah.
Anybody know the pattern?
Is it
Looks like this. 1, 1, 1.
Oh yeah, that.
1, 2, 1.
I saw that when I took the ACT.
You combine the two.
I went 1 plus 1 to get the middle 2.
You
do it?
Yeah, you combine these two. So you fill in the 1 on the outside, then you combine the 1 and the 2, and then you get 3, and then 3 there. And I do this. It looks great.
Awesome. You're good. Keep going.
And then you branch out again, and 4, 4, 1,
Awesome.
and 5,
100 ever stop? Okay. So let me explain as we're going here. So here's Pascal's triangle. Okay, there's some things into here. This is where it comes from. So what happens, you always have 1s out here, and I'll explain why in just a second. And then how we got the 2 is 1 plus 1 is 2. How we got the 3 is 1 plus 2 is 3. 2 plus 1 is 3. Does that make sense? And then I always have 1s on the outside. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay? 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. 4 plus 1 is 5. Does that make sense? It does go on forever, but obviously you don't want to keep doing that. Miss Spangler showed me something that I've never heard before. She said she watched a video on this, and this is what this is. This is the same thing as what is 2 to the 0, 2 to the first, 2 squared, 2 to the third, and I've never seen it. So look 2 to the 0, 1. 2 to the first, 1 plus 1. 2 to the second, 1. I thought it was pretty cool.
I thought it was
2 cubed, 8, 1 plus 3 plus 3 plus 1. I never knew that until just like a half hour ago. She also said that this is the same thing as 11 to the 0, 11 to the first, 11 squared, 11 to the third. Let's check this out. 11 to the 0, 11 to the first, 11, 11 squared. Oh, 21. 11 cubed. Somebody do 11 cubed. I don't know my 11 cubes. I don't know. I'm just seeing if that's the case. Was it? I bet this. Try this to 11 to the 4th to see. I'm just curious. She said that was the pattern to us.
1, 4, 6, 12.
Pretty cool. I never knew that either.
I didn't know what is the triangle used to out.
It's expansion. That's
They're
what
on
it
their
is.
calculator all day, typing in every
She has a good
number
point.
until they find it.
What?
It doesn't make sense. Like, how do you find that out?
I don't know.
How do
Pattern.
you figure it out?
Must be really
They didn't have anything. Okay.
It must be really low.
It doesn't work on the 5th one? Okay, so she said it doesn't work on the 5th. And that should make sense because you got 10s and they're probably looking for digits. Okay, anyway, so as Amber just said, where do we use this? Why is this useful? Well, we are working on binomial expansion. So, what is x plus y to the 0? 1. What's x plus y to the first? Notice the coefficient is 1x plus 1y. Does that make sense? So let's look at the third. So x plus y squared would be x squared plus 2xy plus y. See how I go 1, 2, 1? You guys see that? See 2? 1, 2, 1. 1, 2, 1. What this helps us with is to expand binomials. Okay? Does that make sense what I'm trying to say? So instead of having to continue to FOIL, because we all know even on the third process, FOILing gets a little bit, or distributing gets a little bit old, doesn't it? Right? Could you imagine, because on your thing, I'm going to ask you to expand something to the 8th power. Could you imagine FOILing 7 times? Right? That'd be horrible, wouldn't it? Okay? How are you, Joshua? Good, buddy. I love your suit. It looks nice. Tell her she did good. Okay, so what this does is this allows us, the binomial expansion, to go ahead and expand binomials. Okay? I'm going to show you something else. So if you look at this, x plus y squared, let's just go to here really quick. squared plus 2xy plus y squared. If you notice here, what did the powers always get to? So this went 2. Notice I went from 2 to 1 to 0 for my x's, correct? So notice as I moved left to right, my x's went down by 1 every time. As I moved right to left, what happened with my y's? They moved up by 1, right? Does that make sense? Okay, also, 2, what's the power on x? 1. What's the power on y? 1. What's 1 plus 1? 2. 2. They'll always add up to be 2 in there as well. Okay? So, I'm going to show you an expansion that instead of another way to get this 1, 2, 1 is by doing combinations. You guys remember doing combinations? Did you guys ever do factorials last year?
Yeah.
So, you guys did probability last year too? Okay. So, do you guys remember combinations and permutations? Combination order does not matter, permutation order does matter. Okay? Well, these are just a permutation. I mean a combination. This number 1 is 2 combination 0. When you see that, that means combination. Okay? Notice this says 2 combination 1. This number right here is 2 combination 2. Now let me show you on your calculator where you can find these buttons, okay? So here's your calculator. Okay? So I'm going to hit 2 because that was my leading number. Then I'm going to hit math, PRV, NCR. Okay. And then I'm going to hit 0. What did I get? I got 1, right? And then notice I'm going to do math, or I can do this. I'm going to do this. Okay, I'm going to actually just go second enter. It's giving me the exact same thing, but I'm going to go over and go 1. I get 2. Okay. And then I'm going to go math. Sorry, I couldn't do that. I just like to go second enter. It's a little easier just to switch. Okay. A lot of times it's more than just one person. Okay, does everybody understand how you can find those coefficients using a combination? Now let me show you something about that. Notice, what's the power of y right here? Even though he's not there, so therefore because he's not there, there's a 0, right? There's 0 y, so y to the 0 is 1, and 1 times x squared is x squared, correct? Does that make sense? And notice, what's 2 plus 0? 2. 1 plus 1, 2. 2 plus 0, 2. They always add up to be 2, right? Okay, notice, see how this is 0? That's 0. What's the power on y right here? 1. What's the power on y here? It'll always match up. Okay? So, let's get to something a little bit harder, shall we? Maybe x plus y to the 6. Okay? Could I use Pascal's triangle? That's just the combination that gets you there. I'm going to explain it more as we go, if that's all right. So all you got to understand, this 2 represents the power, this 0 represents how many of the second term there are. Okay? So, we're going to go x plus y. Just 10. Oh, page is fine. Okay, so, looking here, I'm going to expand this. And this is the pattern. Watch me as I go through, okay? This is 6 combination 0. Okay? So, that would be x to the 6th. What is my y power going to be? 0. Plus 6 combination 1. X to the 5th, y to the 1st. Now, understand, my x's are going to go down, my y's are going to start going up. Does that make sense to everybody? Notice, the power on y, or the second term, is always going to be the same thing as that bottom. Okay? Make sense? Now, I should clarify that in just a minute. I'll clarify that in just a minute. Anybody question what I'm doing so far? Give me the next one, somebody. So I'll have first 6 combination 2 x to the 4th plus, y squared plus 6 combination 3 y cubed, right? Am I losing anyone so far? Really simple, right? Okay, and then plus, I'm just going to come over here, plus 6 combination 4 x squared y to the 4th. This is combination 4. This is the same. 4 is the 16. I don't even need to write it. Are you guys okay? Is there something I missed? I'm sorry.
No.
Is this what I'd like to see? Not quite. Now I just want to find my combination. Okay, so I could find 6 combination 0, which is 1. X to the 6th. Plus 6 combination 1 is 6. X to the 5th y. Plus 6 combination 2. Is it? Can somebody guess what that means? Yes. I just like to get seconds. I'm not saying that. Okay, 15. See if I get second. Usually that's more than just 1 person. Okay, so 15 x to the 4th y squared plus 6 combination 3. 20 x cubed y cubed plus, I already know this one. And notice, what's 6 minus 4? 2, 6 minus 2, 4. So these guys flip flop. So this is just the same thing as him, which was 15. So you guys want to try it, I'll tell you why. Just 6 combination 4. I already knew it because it's 6 combination 2 and 6 combination 4 are the same. You want me to show you why I won't? So this would be y to the 4th. You see how they just flip flop these? Maybe just the same thing. I'm going to show you. Okay, and then the last two, this is going to be 6 x y to the 5th, and then plus y to the 6th. And there's my expansion. Now isn't that a whole, I know that still was tedious, right? It was kind of tedious, but at the same time, somebody said the 6 combination 3 was 20. Sorry, where at? Where?
Right there. Right in front of us.
What's a plus y to the 6th? This right here is plus 6 x y to the 6th. Is it? I don't know. I'm just going off what you guys said. See, look right here. So look at my next row would be 1, 6, 15, 20, 15, 6, 1. There's where they're coming from as well. Okay. So you could use either, but on the test, there's a good chance I'm going to have you do something that Pascal's triangle is going to be a pain in the butt. Okay? I kind of want you to get into the math. It's a coincidence where it's coming from, but that's where it is, all right? Now, key thing you got to understand here, this is row 0. Row 1, 2, 3, 4, 5, 6. Does that make sense? Say again? The very top one. 1. Because anything raised to the 0 power is 1. It's a way to remember that. Okay? Alright. So, that's expanding, and that's what I'm going to ask you to do today a little bit. But now, I'm going to get a little bit harder. Okay, just a little bit. Because notice, now I'm going to do this. 4a plus 2b, and we're not going to get too far out on this one. Let's make that a 3. We'll go cube. So I'm not going to get too far out here. Okay? But understand, watch the pattern. Okay? Agree with me? Alright, so with that being said, okay, here's what we got. Notice the expansion. I'm going to do the expansion for you, okay? Now this is representing who? Yes, this is representing the Everybody with me on that? Okay, so therefore I'm going to go 3 combination 0, 4a to the third, y, which is 3b, sorry. And I even start, when I'm getting on these guys, I start writing them out. Okay? Be okay? Plus 3 combination 1. Everybody with me on that? Okay. Yes, because that's the combination. No. Plus, sorry, I'm just running out of room here. 4a to what power? First. Is anybody struggling here? Please talk to me so I can help you with the math. Oh. Because notice, look at my x values started out with the highest power. He's decreasing as we go, right? Yeah. This 3 is this 3. Is that what you're saying?
Yeah.
Yes. Okay, I see what you're saying. And then what's our last one? 3 combination 3. 4a to the 0, which is 1. I'm just because I don't have a lot of space here. 3b to the third. Okay. So obviously this isn't my answer, right? Okay, so obviously this isn't my answer. So here's what I do. 3 combination 0, I know that to be 1. Just think of Pascal's triangle. It's always our first and our last. 1. Now, if you guys know what a combination is, I'm going to come here real quick. It's n and r. Okay? That's a combination. Another way to see it is n combination. Okay? From last year, you guys should remember, not very maybe remember, but here's the formula. It was n factorial over n minus r factorial r factorial. That is the formula for a combination.
Oh, I remember that one.
Right here it is. C. It's a big C. That's how you combine. Okay, now y, as we talked about, y does 6 combination 4 equals 6 combination 2. And let me explain why. So I'd go 6 factorial over 6 minus 2 is 4 factorial. And then notice my r is 2, so this would be 2 factorial, right? Does that make sense to everybody? Yes, no? Just following the program? Okay, now if I did 6 combination 4, I'd go 6 factorial over 6 minus 4, which is 2 factorial, 4 factorial. And you see how these are just linear properties. Oh. Does everybody see that? They're going to be the same. Okay. Does that make sense why they're the same? Okay. So this is my n, which is my r. Okay? N factorial and 6 factorial. 6 minus 4 is 2 factorial. I did factorial. And then notice my r is 4, so 4 factorial. Do you understand that? Plug and chug, right? Okay, now I did him. 6 factorial, 6 minus 2 is 4 factorial, r factorial. See that? And see how they're basically, they are the same, they're just linear properties, right? And that's why they're the same. Does that make sense why we could use that there too? Alright, coming back. Okay, so this guy is 1 times 4a cubed. What's 4a cubed? What's 4 cubed? 64. A cubed, and 3b to the 0 is 1. Is everybody there with me? Yes? Okay. Plus, this is 3 combination 1, which is 3, times 4a squared, 16a squared, times 3b, huh? Everybody see that? Okay. have this 3 minus 2 is 1, 3 minus 1 is 2, this would be the same. It's going to come out to be 3 as well. 4a times 3b squared is 9b squared. Yes, no? 3 combination 3 is 1. 4a to the 0 is 1. 3b cubed is 27b cubed. So now I got to now combine them to make it one solid expansion, correct? Now is this tedious work? Now, I'm not saying it's not tedious work, okay? But it's there. Okay, here we go. So then we got 1 times 64a cubed, which is 64a cubed. Okay. Where am I getting the 1? That's the 3 combination 0, 3 combination 1. I just plugged that in. If you would like to do it in your calculator, I kind of already know the third row of Pascal's. Good question. So we got 3 times 3 is 9 times 16, so that's a $1.44. A squared b. Anybody have a question? Hi, Austin. You're not going to be here tomorrow, are you? 3 times 4 is 12. 12 times 9 is 108. AB squared. Okay? And then we got 27. Miss Spangler said she had a lot of these at first, and then she went last night and switched some out. So we might not have so many expansion. Okay? You guys kind of getting the goal there, though? Okay, I just want to do one more this way, and then we'll get to the other parts of the homework. Yes, ma'am. Because in this case, it does have the 1. See how this is 1? This is 1. There's the 1s at the beginning and the end. Now, because the leading term was not a 1 coefficient, like it was x, and it wasn't just x and y, it was 4a and 3b, you know what I mean? That's the reason. But look at the coefficients 1 and 1. They're here, but then we had to multiply for the other stuff. Did that answer your question? Okay. Let's do another one, last one here, okay? You want me to, we're going to go just barely here. I don't want to get too large on you right now, just because that's not the important part, getting too large. I think you guys see the pattern now, don't you? Okay. And do you see how we do the coefficients by the combinations? We plug those in our calculators, right? Okay. So, but here, this is the next one I want. 2x minus y squared to the 4th. Let's go there. So really quick, because our last one that we just did was a third, that was 1, 3, 3, 1, wasn't it? Okay, notice what does this add up to be? It'd be 1, 4, 6, 4, 1. So I've already did my combinations if I wanted to, right? So if you can, obviously it does save a little bit of time, right, by doing that. But at the same time, understand the combinations because that helps us coming into the next one. Okay? Alright, so let's try and expand this. So, we have 1, 2x to the 4th negative y squared to the 0. Everybody understand where I got that? Because notice in the binomial it's plus something, so I can make this a plus of negative y squared. Does that make sense to everybody why it's negative y squared? Okay, so going back to the original, right here, notice it was x plus y on our
I
extension.
said yeah.
Oh, I thought you said
No, somebody else
no.
said
Who said no, so I know where to go talk to. Alright, the x plus y, now notice if it's ever a negative, isn't minusing the same thing as plus a negative of that value?
Yeah.
So it always has to be a plus here. Okay, so that's why here on this one, my second term is negative y squared. You okay with me now? Okay, so now I'd go plus 4, 2x to what power? 3, negative y squared to the first. Okay? Plus 6, 2x squared, negative y y squared squared. Well, the administrators come together. That's about where I'm at. Plus 4, 2x to the first negative y squared cubed. Last one, 1, 2x to the 0, negative y squared to the fourth. Okay, that's our expansion, but it is not a simplified expansion, correct? Okay, by the way, this would be 6 combination 0, 6 combination 1, 6 combination 2, 6 combination 3, excuse me, why am I saying 6? 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, 4 combination 4. Yes, sir?
That's where that y squared would be negative with a negative go outside of the square.
No. Outside of that, no. It's part of it.
So you could technically get rid of that.
Like when I square like this guy, he will get rid of it. Okay, here we go. So let's finish this guy up. Okay, 1 times 2x to the fourth. What's 2x to the fourth? What's 2 to the fourth? 16. X to the fourth. With negatives to the 0, anything to the 0, that's just 1, right? So there we go. Okay, next one. Okay, 2x cubed, that's 8x cubed times 4, 32, but this guy's negative, so that's negative 32x cubed y squared. No, I don't need to put plus. Does everybody see where that's at? Do I need to talk about that? Okay. What's negative y squared to the first? So I have a negative y squared, and then this becomes 8x cubed times by 4. So I have 4 times 8x cubed, which is 32x cubed, times negative y squared, and it's negative 32. So you want to see the work behind it, or is that not how that's the order of the ready? One more time. So I'm going to just expand him out. So I have the 4 times 2x cubed, which is 8x cubed, times negative y squared, which is negative y squared, right? With me there? 4 times 8 times negative 1. Pi. A worksheet, it's over on the side. Are you okay with me now? Now, so here, then I got 6, and sometimes I even do a little work underneath it. I write 6, 4x squared. Now this becomes positive y to the 4th, doesn't it? Does that make sense? Because negative y squared times negative y squared becomes y to the 4th. Should be 24 x squared y to the 4th. Now notice, guys, beforehand, what's the power that these guys should add up to be? 4. And here they are. Look, 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, 0 plus 4. And down here they won't because I have a variable inside. So obviously that flips it out a little bit, correct? So they won't always add up to be the same thing. Okay, yes ma'am. What do you mean by that? So like, how do I know this goes 4, 0, 3, 1? Because as I go left to right, my x term, which is always going to be your first guy, starts out with whatever power it is. And then you decrease it as you go through. Does that see how it's decreasing? And then as you go along, it starts with 0 and it starts increasing. Does that answer your question? Okay. Yeah. Okay. So now I have 4 times 2x. Notice negative y cubed would become negative y to the 6th, won't it? Because it's cubed, so therefore negative, negative, negative becomes negative still, right? We got to really hustle. This has got to be my last one on this, and I forget my good stuff. Okay. So with that being said, this is going to be negative 8xy to the 6th. And then last but not least, 1 times 1 times y to the 8th is plus y to the 8th. Okay. With that being said, what term does this represent? first term. What represents here? Second, third, fourth, fifth. Does everybody understand that? There's one more term than the power. Because notice, think about it, if you had x plus y to the first, you have 2 terms. If you had x plus y squared, you had 3 terms, and so forth, right? You're always going to have one more term than there. That's why we also go with this being 4 combination 0, and so forth, right? You start with 0, 1, 2, 3, 4. Okay? So, if I asked you now, okay, if I had x plus y to the 8, okay? I don't want to expand that. I want to know what is the 5th term. Without expanding, how can I do this? So it would be 8 combination 4. Anybody tell me why it's 4? Because we start at 0, right? 0, 1, 1, 2, 3, 4. We start on 0. So 0, 1, 2, 3, 4. Okay? So then this would be x to the, we don't know, but we know that this power and this power are the same. This number and this number are the same.
They have to add up to 8.
And they know they have to be added up to 8. Then we just go put them in the basket over there. Okay, let's go over the thought process one more time, because that's exactly what it is. Maybe a little fast so everybody can understand. Okay? 8 comes from the power. 4, because we're looking for the 5th term, we have to go 1 less than that. Because also, you remember, well, how many y's are in the very first term? Y 0. So that's why I would go 8, 0. Because remember, the power on y matches the r value of the combination. Correct? So because I was looking for the 5th term, that's 8 combination 4, right? Because you're 1 less. Remembering that the y matches, correct? And then notice, as Kennedy said, what do the powers have to add up to be? The power, correct? Does that make sense? So then we got to find out what 8 combination 4 is. So I go second enter. Seven. So I come back over here, and this is 70 x to the 4th y. That'd be the 5th term. Does everybody understand that? Should we try another one, a little bit harder?
Yeah.
Okay. Okay. Huh? Okay. So once again, what if I have like 3x minus 2y raised to the 10th, and I want the 8th term? 10 combination 7. Does everybody understand where that guy comes from? 1 less, 8th term, 1 less, right? Okay, therefore then, do I just do my x? No, I take 3x and negative 2y, correct? Because that's technically my x term and my y term. And so who is the one being raised to the 3rd? Okay, because this guy and the y guy always match up, right? This guy and the y's power always match up. And then these guys together have to add to be the original power. Okay, so this guy's 120. 3x cubed. 27x cubed, right? I don't know if I guess I could. I think it's negative 128. Okay, negative times by negative 128, y to the 7th. Somebody hook me up. 120 times 27 times negative 128. So obviously a good calculator helps us here, right? Okay, read me as a number.
400,014,720.
so it says 414,000. I just need to erase that. I mean, that's 7. There it is. It's just not spaced together. Okay? So with that being said, there's the number. And then we got x cubed y to the 7. Pretty simple, right? Okay, one last one. Okay, one last one. Now, what if I gave you this? 5x plus 2y raised to the 8. Again, I don't know why I'm doing 8, but it is. And then I came up and I said, what is the coefficient if I told you that this is x cubed y to the 5th?
Is it 7 or a 2?
That's a 2 because it's not crossed, right? 8 combination 5, we know that for sure because the y, right? So therefore that's 8 combination 5. Give me 1 second. But the key thing here also, guys, is you got to say, technically my x term is 5x. So I got to go 5x cubed. Does that make sense? Because it's not just the 8 combination. This 5 and that 2 affected as well, don't it? Does that make sense? And then this would be 2y to the 5th. So now it's kind of like what we did last time. It's just helping us get the first. Instead of using what term it is, we looked at the coefficients, the powers on the exponents to help us find out what the combination was, right? Okay, so therefore, help me out. Somebody 8 combination 5?
It's 50,000.
This is 56,000?
That's just 56.
Oh, I thought I heard 1,000 after that. 5x cubed would be 125 x cubed times 32y to the 5th. So now, 224,000. Straight up. And then that's what we want because we already knew what x to the 3rd y to the 5th is. That's the coefficient we plug in. Correct? How do you guys feel? I believe that's most of it. Please make sure, I believe there's some questions on factorials. Okay? So just remember, n combination r is n factorial over n minus r factorial r factorial. Once again, this could also be written as nr. Okay? Okay, if you have these worksheets, please, yes, turn them in. Okay, awesome. Will you come show what they got for me, actually? Okay, guys, I appreciate you.